Okay, I think we finally have video capability here. So let's review for the logarithm exponential test. First page is going to be non-calculator, separate sheet. You just have to use properties of logs and exponentials to solve the problem. If you have two things of the same base here, when you multiply, that means you add the exponents. So that's how you get 2 to the 12th. In number 3, you're dividing, so you're going to subtract the exponent. So 8 minus 2 gives you 6. Keep the same base. Don't try to make it, 4 to the 12th or, 10 to the 10 here or 1 here, something like that. Make sure you stay base the same. Raising power to a power, you multiply the exponents. That's why it's e to the 12th. Next one's with logarithms. When you're adding on the outside, that means you multiply the two numbers on the inside. So that's why it's log base 4 of 40. When you're subtracting, well, adding was multiplying, subtracting means dividing, so you just put it as a fraction. If you can simplify the fraction, do so. And then number 6 here, when you have a number out in front of a logarithm, you can bring it into the log by putting it in the exponent. So 5 to the third is what would be on the inside. Number 7 here, this is one that can't be simplified. You won't get one of these on your test, but just the common mistake that people would try to say here is trying to make that a 9, because 8 times 9 is 72. Make sure you remember it's all about the exponent. Last one's just rewriting it. Okay, so you rewrite these. Remember, ln means log base e, so base to the answer power equals the inside. Same here, base, there's no base, so we assume it's 10. To the answer power equals the inside. We're here writing it as a log base, whatever your actual base is there, 9. The exponent becomes your answer, and the original answer goes inside the log. So mainly, your base is still your base, your answer and your exponent flip-flop spots when you go back and forth between a log and exponential. Alright, solving problems. On any of the exponential problems, your first thought is, okay, can I make everything have the same base? So in 11 and 12, I can turn everything into the same base. In 11, the base is going to be 5. 5 to the first power, 5 to the second power, and 5 to the 0th power gives you 1. So rewrite everything as so. When I do that, 5 squared is what I put for the second guy, so I'm going to multiply the new exponent. 2 times the quantity 3x minus 5. And again, now I have everything with the same base. To combine guys with the same base by multiplying means I'm going to add my exponents here. And now once the bases are the same, that just means the exponents are the same. So 4x plus this whole quantity, the 6x minus 10, equals this exponent 0. And now I'm just solving the problem, solving the generic answer to get 1. In 12, what number can I raise to get 16, 4, and 32? A lot of people would try to say 4 because 16 and 4 work very easily with that, but you can't get 2 or 32 that way. So your base here needs to be 2. 2 to the 4th gives you 16, 2 squared gives you 4, and 2 to the 5th gives you 32. Notice I just rewrote each of the 3 bases. From here, again, I'm multiplying, so I'll add my exponents. So that 8x minus 12 here, I'll be adding negative 4x, and it'll equal this exponent, 5. Because once the bases are the same, again, exponents are the same. Then here, just solve like normal. 4x minus 12 equals 5. Bring over the 12 to make it 17 divided by 4. 17 over 4. Now, in this one here, you have some extra stuff going on. 8, 9, 15, 3/4, they all have very different bases. Well, what I should try to do now is, well, can I do some basic algebra to try to fix the problem? And yeah, that's what I end up doing. I subtract 9 from both sides first. So I would get right here 3x, or 3/4 times 8 to the x equals 6. To get rid of that, I'll multiply both sides by 4 over 3 power. To get rid of that, I'll do the same over here. Multiply by 4 over 3. So 8 to the x equals 8. Well, now I have, again, same bases. 8 to the x equals 8 to the first, so the exponents have to be the same, x equals 1. Number 14, same idea. Try to do some algebra first because I can't raise anything to get 5, 12, and 11. So I subtract 12 from both sides first. Subtracting 12 from both sides. Subtract 12. When you do that, 5 to the 4x minus 7 power equals negative 1. Well, remember, an exponential can never equal a negative number. That's why this is a no solution. This is dips, because an exponential can never equal a negative. It's just like a square root. Okay, next problem. Same idea. first try to raise things to powers, can't do that. So now what I'm going to do here is I'm going to try to just simplify. Well, I should be adding 1 to both sides. So of course, naturally, I already have a bit of a boo-boo on my thing. So this should be 18 when you add 1 to both sides. Well, I can't raise anything to power to get 3 and to get 18. And be careful again. 3 times 6 gives you 18, but it's not 3 raised to a power, so that's not going to work. So what you're going to do is you're going to take a log of both sides. You will do a log base, whatever this number is, log base 3 of both sides. That's what we do to get rid of the exponential. So log base 3 of both sides. Those cancel out, leaves you with 6x plus 1 equals the log base 3 of 18. Now it's just basic algebra. I'll subtract 1 from both sides, divide the whole thing by 6. So you get log base 3 of 18, then subtract 1, then divide by 6, and you get an answer of, it's probably about 2.7 something, I don't know for sure. But the main part is, you're going to type this into your calculator. Remember, you type into your calculator log of 18 divided by log of 3 to do the log base 3 of 18. Number 6. 16, I should say. Do your algebra first, subtract 4 to make this now equal to 2 on this side. So this is now equal to 2. Divide by 6. So you get 2 over 6, which divides to 1 over 3. Well, I can notice here that, again, I have something that could be raised to a power. 3 squared gives you 9. 3 to the negative first will give you 1/3. Negative exponent flips to fraction again. So now the bases are the same, just like before, exponents are the same. So 2x equals -1, x equals -1/2. Pretty straightforward. Number 17, same idea. We have an e. Don't let that throw you off. Just solve it like you normally would. I'm going to get rid of the 4.1 by adding it to both sides. Excuse me. And you get e to the x squared equals 13.1. To get rid of an e, you need to take the natural log of both sides. So that's what we do here. We take the natural log of both sides. Natural log of e cancels out. X squared equals ln of 13.1. And then to get rid of a squared, you take a square root. Remember, when you take a square root, you also need to include plus or minus. So it's plus or minus the square root of 13.1, which turns out to be plus or minus about 1.604. Okay, and the last one, also you can do everything with the base of 3. 3 squared is what gives you 9. 3 to the first gives you 3. And 3 to the fourth would give you 81. So 3 to the negative fourth power would give you 1 over 81. Now, I have a big fraction here. Remember, when I divide guys of the same base, I'm going to subtract. So I have here subtraction of those exponents. So 12x plus 4 from the top exponent, 12x minus 1 for the bottom exponent. I subtract them, and I get equals -4x for the exponent on the right. Make sure you remember to distribute this negative through, probably the biggest issue with that one. Then you're just solving like normal. -5 over 4 ends up being your answer. Alright, 3 more dealing with logarithms now. With logarithms, what we're going to do first, let's look at number 21 first. In 21, you have log of something equals log of something. If the logs are the same, you can just get rid of the log and focus just on the inside. 5x minus 8 equals x squared minus x. Solve just like you normally would. In this case, you get 2 answers, x equals 2 and 4. Remember, you should always plug back in and check to see if these answers work. Meaning, do you get positives? Remember, you cannot take a log of a negative number. It's just like a square root. Can't take logs of negative numbers. So when I plug in 2, I'm going to get numbers that work. When I plug in 4, I also get numbers that work. So both of those work out just fine. In number 22, let's do that one next. They're all log base 2, but I need to only have just 1 on each side. I need to combine these two into one big logarithm. Well, when I'm adding in between, that means I multiply the parts on the inside. So that's how 8x minus 3 times 4 gives you the 32x minus 12. Now I just have 1 log on each side. I can just get rid of the logs and set the insides equal. I get an answer of 2 over 31. Again, I should plug this back in and check. And I can plug it into any one of them, but here's what I'm going to notice right here. If I plug it into this guy on this side, 2 over 31 minus 10 is definitely going to give you a negative number. So this guy really should be a extraneous solution, a no solution answer. Even though when you plug it in here, it's going to work, 2 over 31, or it might work, I'm honestly not sure. when you plug in here, it definitely does not work. So just make sure you check everything. Now, 19 and 20, what you're going to do here, because we don't have logs on each side, we need to undo a logarithm by doing an exponential. If there is no number, we assume it's log base 10. So I'm going to raise each side to the 10th power. So that means those cancel out. X minus 3 will equal 10 to the 4th. I just have that written backwards here. So that means to get x by itself, I'm going to have 10 to the 4th, and then what? I actually add 3 to both sides. 10 to the 4th plus 3. So your answer ends up being 10,003. 10003. You can tell, wasn't myself when I made this review, was I? Number 20. To solve number 20, what you're going to do here is you're going to get the natural log by itself. In this 19, we already had a log by itself, so we could just raise it. We can't until we get it by itself. So first I'll subtract 12 from both sides. So it gives you the 5 ln of 7x will equal 15. Divide both sides by 5 gives you ln of 7x equals 3. To get rid of a natural log is again log base e, so I'll raise each side to the e power. So the e and the ln will cancel each other out. 7x equals e cubed. To get x by itself, I'll divide by 7. So x will equal e cubed over 7. That's actually an exact answer. I would much prefer that. If you turn it into a decimal, 3 decimal spots as always, 2.869. Okay, last couple. And 23, a lot of people are just going to try to say 3 times x equals 8 because you have log on both sides. Well, we can't have anything extra with the log, so I need to first bring that 3 back into the logarithm itself. Remember, we can bring it inside as an exponent. So log of x cubed equals log of 8. Now I have log of each on each side. I can get rid of them. X cubed equals 8. Nice and easy. X equals 2. 24, ln on both sides, so I can just get rid of the ln's and make it really straightforward and easy. Now the insides are the same. 9x minus 4 equals 1. Add 4 divided by 9, x equals 5 ninths. One thing to remember, logarithm of 1, any log of 1 equals 0, because this means e to the what power gives you 1, or anything to what power gives you 1, it would be 0. So that could be another way, if you needed to, figure out exactly how to do that. On some problems, remember any log of 1 equals 0, and remember any number to the 0th power is always going to equal 1. Alright, there you have it. Best of luck, and I think you're going to be just fine. Good luck.